In this question, we have been asked to find out the number of equivalence relation in A containing 1, 3, and the relation A is given by 1, 3, 5. Now, in order to find the number of equivalence relation, first let us understand the equivalence relation here. Equivalence relation is that relation which is going to be reflexive, symmetric, and transitive. Now, let's start with it one by one. Now, if I'm going to take out a relation R1, and if it has to be reflexive, then it has to take all the elements, that is A, A should be belonging to R. So I'm going to take 1, 1, 3, 3, and 5, 5. So with this, I can say relation R is reflexive. Next, I need to go out with symmetric. Now they have said that this relation A should consist of 1, 3. So now if I'm going to include 1, 3, then 3, 1 should also be included in order to make it symmetric. So now I can say this R1 is an equivalence relation. We will try to take out all the possible pairs of the relation A. So now this relation A, which can be taken as R equals to, I'll take out all the possible relation of 1, 1, 1, 3, 1, 5, next 3, 3, 3, 5, 3, 1, 5, 1, 5, 3, and 5, 5. Now, if you're going to see here, we have already taken 5 elements. That is going to be 1, 1 is done, 3, 3 is done, 5, 5 is done, 1, 3 is done, and 3, 1 is done. Now I'm going to take out one more relation R2. Now since they have told it should contain 1, 3, so it should contain all the elements of R1 in order to be equivalent. So first let me take out all the elements of R1, which is 1, 1, 3, 3, 5, 5, next 1, 3, and 3, 1. Now if I'm going to add one more element, that is going to be 3, 5 to this one, then in order to be symmetric, I need to take 5, 3 as well. Next, in order to be transitive, since I have 1, 3 and 3, 5 in the relation, then I need to have 1, 5 also in this relation in order to be transitive. Next, and if I'm going to look into this, if I have got 5, 3 and 3, 1 in this relation, then 5, 1 should also be there in this relation in order to be equivalent. Now, if I'm going to compare this R2 with the original universal relation R, then I can say that R and R2 are exactly same. So we have got two possible equivalence relation here. One is R1 and second one is R2, which is nothing but the original one. So I can go out with option B, which is nothing but 2.